Hey everybody, got another power supply repair video. So this power supply here is a Delta model DPS-300AB-24 B. I featured this unit in a prior video. I bought this unit as well as a Bestech ATX312Z as a lot on an eBay auction, or as a buy it now. It wasn't much. It's like, I think, 20 bucks or so for these two units, and they were both listed as for parts and repair. I did invest in time in trying to repair the Bestech and could not get it to come up. However, in a prior video where I was successful at repairing a Bestech ATX312Z unit, it was capacitors that was preventing the unit from starting. And this Delta power supply is exhibiting very similar symptoms. It has working 5-volt standby, but it will not power up otherwise. It just does nothing, and the green LED on the back goes out. So right now I have green and black jumpered, and I have this little USB powered fan connected to the 5-volt standby rail to apply some load, because that was how I determined in the prior Bestech video that it was an issue with caps that was preventing the thing from starting up. So this Delta, while it does not stay on and run, I did notice when applying some load to the 5-volt standby rail, it attempts to start. You'll see the fan twitch, which there's other failed caps in this unit, and I should note that yeah, they're actually visibly bulging. So this unit's going to need a recap for, obviously it's going to need a recap, but I did want to see if perhaps it would start. So I got this safety ballast hooked up to it. So basically this light bulb passes power. The live is actually fed through this light bulb. Alright, that being said, let's go ahead and first, you gotta make sure the USB fan is off. I'm going to turn on mains power to it. Watch what happens here. So you may have or may have not seen this light bulb pulse. Right now the rear LED on this unit is off. Let me zoom the camera in a little bit here. And I'm going to turn on this USB power fan. Watch what happens to the fan in the unit. So you see how it just moved a little bit? Now switch it off. Does not pulse that time. So I'm thinking possibly there's a short in the output on this unit. I think the short circuit protection was what stopped it, because the supervisor acts as a crowbar circuit. So more or less what that means is, while there's still a call for power on from, let's say, the motherboard, the supervisor will trip out and latch the unit off in the event that basically it trips out for whatever reason, due to overvoltage protection, undervoltage protection, or short circuit protection. So if I power this off, I'm going to turn off the mains power, turn on the USB fan. That just expedites the draining of the capacitors in the unit. So it's very well possible we might have a shorted capacitor on the secondary. I'm going to do this one more time. This time I'm just going to turn on power with the USB fan already on. You see how it twitched a little further there. So that's a good sign. That tells me that it's possibly little capacitors similar to the Bestech that's preventing this thing from starting up. So chances are, with a full recap, or as close to a full recap as possible, we could resurrect this unit. So that being said, I'm going to let this unit discharge for a little bit, and I'm going to open it up and we'll get started on it. Okay, let's go ahead and pull the cover off this thing and have a look inside. What's nice about this unit is it has a clamshell style cover. That's all it takes to get the cover off of this thing. So we're in. Now I should note, I think I've been in this thing before, because I peeled off this foam that was down here because I was trying to inspect, or at least look at the traces to see if there was any issues. But there's nothing I could find, at least. And one thing I think Delta might have messed up on here was using adhesive backed or double-sided tape or material similar to that to secure this foam to the bottom of the board, because we have kind of a mess here. It's kind of hard to get this off. Now chances are this will be fine, but sometimes I do wonder in the back of my mind if this could perhaps flash over, because these units have 340 volts roughly DC in them when they are plugged into the wall. So anytime they're plugged in, they're energized with 340 volts DC. And there is the concern that this stuff could cause it to flash over, and that would be pretty ugly. Let's go ahead and have a look at the capacitors. Now, we do have some bulging caps in this unit. What a shocker. Bunch of looks to be LTAC and some others in there. I think there's a possibility that some small caps are messing with this thing, causing it to not want to start up. It does have an IC controlled 5-volt standby circuit. There's a tiny switch over here. It's a TNY266PN 8-pin IC, and over next to that we have the PWM controller, which is in this unit it is a UC38438, which I think is the same as what Bestech uses. Yep. Actually, no, that one's slightly newer. So, slightly different PWM controller. Now, despite this unit coming from the same eBay seller as the failed Bestech ATX312Z unit that I ended up scrapping, this one does not appear to have the moisture damage, or it doesn't appear to be exposed to a lot of moisture. The Bestech had a little bit of surface rust on parts of the casing, and some of the metal parts inside had a little bit of like corrosion on them. So yeah, this one looks like we could possibly save it. I'm just looking at the caps in here because I've never serviced one of these, so it's going to probably end up being a replace caps one or a few at a time. I got to get this glue off of this one here because well, it's kind of in the way. I don't understand why they put that glue there, of all places. This has like a silicone type adhesive in it, which is better than the tan or yellow glue that Bestech and Hypro used in their units back in the day. This one is newer. I want to say this thing is probably from around 07, 08 possibly. Came out of a Dell system. You see the Dell sticker there. So we're going to just change these caps out and see what that gets us. One thing I don't like about the clamshell is you kind of have difficulty getting access to some of the stuff in here, but I'm going to take the 4 screws out of here to release the PCB from the clamshell. That should allow me better access to the circuit board. Should be able to lift this up now. So I understand most of my viewers watching this probably don't want to watch the whole thing drawn out, so I guess I'm going to time lapse this that way I can do this and listen to other stuff on YouTube or whatever while I'm working on it. Just roll the camera. So anyways, here we go. Okay everybody, so we're going to explain what's going on here. So I didn't get footage of installing the replacement capacitors, although I did get footage of removing the old caps, and that was quite a job in this unit. I mentioned earlier in the video that I like the clamshell design, but in a way I kind of don't like it, because the traditional power supply design, you have the cover that comes off exposing the top and the sides. It makes testing the unit a lot easier, but I was able to work with this thing, and I had to spend extra time on the joints getting them to melt, because this unit of course has that wonderful RHS compliant lead-free solder junk, and it don't melt as easily as, let's say, traditional leaded solder. So it was a bit of a chore getting these caps out. Once I got them out, I then jotted down their location, their ratings, all that stuff, and then I went back and used some fresh 6040 lead solder on the joints to clean them out, or to clear them out. Mix in some fresh solder with the existing solder, and then use a solder sucker to suck it all out, because once you mix some fresh solder in, it melts a lot easier. But got all the joints cleaned out, that way I could easily install the replacement capacitors, because the replacement caps have really long leads on them, making it easier to aim them to the holes on the board and install them into place. But the reason why I didn't get really any footage of installing the replacement caps was because as soon as I got this board cleared out, I focused on that residue, or that foam, what was left over on the high voltage side of the unit. I was not comfortable with that stuff remaining there. I think Delta made a huge misstep by putting this stuff directly on the board like that. So getting that off was quite a job. It took several different types of solvents to get that stuff off of there, and a lot of scrubbing with a toothbrush. Yeah, but as you'll see, I managed to get it cleaned up. Okay everybody, so I've got all the replacement caps installed into the board. That's got to solder them into place. I've also taken some time to really try to clean up this adhesive left over on this PCB on the high voltage section. While Delta is a decent manufacturer of power supplies for the most part, they're known for really decent power supplies, they kind of missed the mark here. They should not have put, well, I don't think it's the best idea to secure foam directly to the circuit board using double-sided adhesive, because with time, the concern I have is that double-sided adhesive, or just adhesive in general, could become conductive. And in the case where I had to repair this board, I had to rip that foam off of the board, and that left behind the adhesive, and I was concerned that the adhesive, while itself may not be conductive, it could attract dust containing particles that could be conductive, and that could possibly result in a future flashover in this unit. So what I've done is I have there's still a little bit left over, but it's nowhere near as bad as it was. It's nowhere near as sticky. But yeah, I spent over an hour last night just getting that stuff off of this thing. I used several different things, including WD-40, which I don't exactly like using on something like this. WD-40 was good to help dissolve the adhesive, and I used, let's see, this labeled adhesive remover. It's got like citrus in it, has a citrus smell to it, and I've used this stuff here, which is for RC car motors. The closest thing I could think of to this would be MAF sensor cleaner for working on cars. It's the electronic safe version of brake parts cleaner, to put it that way. Very strong solvent. And see that along with a toothbrush. Just scrubbing this thing, having to be very careful to not damage any of the surface mount components on here. So basically a whole lot of like this. And of course I didn't get footage of that because I think that'd be pretty boring to watch. But yeah, jeez, that was yeah, pretty disappointed I had to do that to this thing. But anyways, here we are. Let's go ahead and get these capacitors soldered in. Now I think it's raining outside, so I don't know if we'll be doing any back porch testing tonight of this unit, but we shall see. I could take the risk and test it right here on the bench, but if it blows up, it's going to be loud and also stink the room up. I've had power supplies fail before. Not a pleasant smell. Okay, so I got a replacement cap soldered in. I should note that when I was selecting capacitors for this unit, I had to make a few substitutions. Nothing major. Generally, with like the filtering capacitors on the output stage, you can safely, I'd say, go up a little bit on capacitance. And of course, you can go up on voltage. Now, the voltage rating on a capacitor, it's just, basically it's the withstand voltage, meaning it's what the capacitor is capable of withstanding. Or, yeah, you don't want to exceed that voltage. As a matter of fact, you want to try to have a comfortable buffer between the voltage in the circuit and the voltage of the capacitor. So, in some cases, this unit had, let's see, 25 volt 100 microfarad capacitor. I think I replaced it with a 50 volt 100 microfarad capacitor. So still 100 microfarad capacitor. It's just the withstand voltage is doubled than compared to the original capacitor. So I had to make a few substitutions. Hopefully it'll be no big deal for this thing. One more thing I'm going to go ahead and do is this fan I'm not so sure about. It's got a sun-on fan, I think, and sun-on fans, they're not the greatest. I've seen a lot of them either make a lot of noise, like the bearing dries out, or just outright fail altogether where they seize up. And this one, I'm going to pull it out and just have a look at it. It definitely feels like the bearings are, oh yeah, I feel it vibrating when I spin the fan. So this fan, Oh, wonderful. This is why I don't like these newer fans. I prefer the fans that have a rubber cap that you pull off where you can simply service the fan, like service the bearing. Like, how difficult is that got to be? But no, you get this. It's non-serviceable. And it's funny, I'd received some comments in one of my prior videos about my soldering. Well, yeah, look at that right there. Yeah, that wasn't my doing. That's Sunon's doing there. But let me go get a replacement fan for this unit and install it, and we'll go ahead and throw this thing back together. And if it stopped raining out there, I'll back porch test this thing. Now, I do also want to get rid of any residue from last night when I was trying to clean this thing. I had a little bit of run over, nothing too major. I do think Delta made a mistake by using adhesive to secure the foam over the high voltage section. Like, I've seen units before where they use that stuff, and instead of using the adhesive, they just use maybe a little double-sided tape in the corners where the whole thing is not just covered in adhesive. Or in some case, they just set the foam in there. They don't actually secure it with adhesive to the board. I mean, it's not like it's going anywhere. So I don't understand what the deal was with the adhesive. Now, I think it was a bad move on Delta's part to do that. But anyways, let's go and get a replacement fan, and we'll get this thing put back together. Okay, so I found another fan that has the same style connector as the stock fan for this unit. However, I should note the polarity in the connector is backwards. So same style connector, it's just the polarity is backwards. So what we're going to do is we're going to have to swap those around. Now, these style connectors, what you need is a very fine screwdriver, tweezers, or anything that you can stab down in there to push a little metal tab down, and that releases the metal contact and allows it to slide out of the connector. So we got to pull both out and then switch them around. Alright, so what we're going to do here is we're going to have to bend this tab back out. That way, when we push this connector back in, it will lock into place. I'll just grab our old Sunon fan just to make sure we're putting this in the right spot. And you'll feel it lock into place. Double check. It'll work. Yep, good to go. So I'm going to pull this sticker off here, and I'm going to lube this fan. Apparently I've done it before, but or maybe that's just a factory lube. Surprisingly, this fan is not dry of oil, but I'm going to go ahead and apply some fresh oil just to make sure we're good to go here. Alright, so in case you're wondering what kind of oil you can use on something like this, this was some old stuff I got many years ago when we purged a lot of stuff in my place of work. But a good oil that you can use is 3-in-1 electric motor oil. Not just regular 3-in-1 oil, although you can use it. The 3-in-1 electric motor oil is just better for this kind of stuff. It's not as prone to drying out. Alright, so I'll go ahead and reapply the little rubber seal. And this fan spins perfectly fine. Alright, so we're going to go and get this installed. And of course, do not forget to plug in the fan connection. Alright, so now we're going to flip this back over and let's get this PCB secured back into place. Okay, so before I put the cover back on, I want to secure these wires back into place. And since we changed out the fan, the new fan, the wire is much longer than the original. So we gotta do something with the excess, and that's going to be securing the wires using a zip tie. Now, if this were a clamshell style case, I would probably back porch test this thing open, but since it's a clamshell, I'm going to button it back up. And I'm just really hoping this one pulls through and works. I think one of the downfalls on this unit is the fact that Delta used that adhesive on the back of that foam. A mighty dumb decision in my opinion. And of course, on top of using crap capacitors, if they used legit, decent quality, like Japanese capacitors from the start, this unit would probably still be working just fine without any issue. But here we are. Okay, so now it's ready for the cover. I really hope this unit pulls through and works. Before I close up, let me check one more time at all the soldering joints that I worked on. Like I say, with the adhesive, I really hope we don't have any issues with that. I got off as much as I could. So this thing was missing a screw on one side, so I found a replacement here I can stick in there. Alright, I'm gonna be honest with y'all, I'm a little nervous with this one. It's quit raining outside, so I'm gonna back porch test it. And I got this paper towel here across the top vent because I don't want any chance of a raindrop going in this thing while it's outside. So let's back porch test it. Alright, so we got it set up out there, and well, of course the wind, it's enough breeze to blow my paper towel off the top of that thing, but it's not raining out there, so alright, let's test it. And of course we're using the safety ballast that'll at least stop from tripping the breaker or blowing the internal fuse. Alright, here we go. And it looks like it's working. See the lights on. Looks like the fan's running. Yep, fan's running. It's a runner. Not sure how fast that fan's spinning though. Yeah, that fan's going really slow. I may have to find another fan for this unit, to be honest with you. Or it could be the fact that it's pretty chilly outside, but we have to consider that probably the slow fan speed was what contributed to this thing losing its capacitors, or at least causing its capacitors to fail. But hey, at least it's running. That's a good sign. So I should note that I have this little fan here. It's an adhesive fan. This came out of, I think, a power supply from the Optiflex 390. And it's rated at 0.25 amps. So what I may do while this thing's running out on the back porch is I will just swap over the connector from the old fan to this one. That way I can change that fan out if I think we need to change it. Okay everybody, so I just got done swapping the fan with that other one. And also while I was in there, I noticed I missed two capacitors. They're actually right next to the PWM chip in the primary section, and I went and changed those out. There was a little LTAC. Both of them were LTAC. One was a 1 microfarad, the other was a 4.7 microfarad, both 50 volt rated parts, and went and changed those out with some Rubicon equivalents because, of course, although this thing successfully powered up, I did go and change out those caps because it wasn't not long ago I had to change a bad LTAC 1 microfarad 50 volt cap in a Hypro unit because that was causing it to not get power good. Alright, so we're going to back porch test this thing again. So let's go ahead and apply power. And it came right up. Not a problem. Alright, let's get a flashlight and let's see what that new fan is doing. See if it's running a little faster. Yeah, that's better. Much better. I can actually feel it, more air coming out of it now. Alright, I'm going to go ahead and test our voltages. So it's actually pretty important that when you're changing a fan in a power supply unit, that you locate a fan that's similar in like specs to the original fan as far as rotational speed is concerned, because if you go from, say, a fan that spins fast to one that spins slow at full speed, it's really going to spin slow in a unit that has fan speed control. Alright, I'm going to check our voltages here. 3.3 is coming in good, 3.33. Minus 12 is minus 11.96. Our plus 5 is 5.11. Yeah, this thing's solid. Let's see what our plus 12 is. 12.12. Let's check our 5 volt standby. This unit uses a IC controlled 5 volt standby circuit. 5.06, that's good. Alright, this thing, I'd say, was a successful repair. Went from refusing to power up to coming right up, and at least at no load, having really good stable voltages. Unit runs very quiet, no hissing, no screeching sounds. I think we're good to go with this one. Okay, so I'd say that was another successful power supply repair. We changed out all the caps, all the electrolytic caps except for the two big ones in the primary. Those are working fine. And also replaced the fan and gave this thing a good cleaning to get rid of all that old adhesive mess where it had this foam on the bottom of the PCB in the primary side. That foam doesn't have to be there, but it would be nice though if they would not have used adhesive to like stick it onto the board like that. It's just not a very smart idea in my opinion. But Delta power supplies, they're among the best of the OEM units, although even Delta's had issues with capacitors and just stuff like that. Pretty much all the OEMs of power supplies. Delta, Hypro, Lite-On, Bestech, Acbel, they all seem to suffer from capacitor issues because they just could not seem to use Japanese capacitors in their units from the start. They always had to use Chinese caps, and well, you get what you pay for. So anyways, that's our first video. Hope you enjoyed it. Thanks for watching.